when you see a triple bond, all right, or you see an alkyne, we use the suffix "-ine" at the end of the name. All right, let's take a look here. So an alkane we call pentane, 5 carbon. An alkene we call pentene. An alkyne we call pentyne, 1 pentyne or pent 1 and I. Put 1 in between right there. All right. Step 2, if you see a carbon-carbon triple bond, that's your parent chain. The parent chain has to include it, right? Not like alkane. Alkane, we take the longest chain. For this one, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 carbons there. Count from the right side, you're going to get the ethyl group at the lowest number, right? This one we call it 4-ethyl octane. Okay. Now, for alkyne, you have to count, your parent chain has to include the triple bond. Right, the triple bond has to be in there, and the triple bond has the lowest number. So when they start counting from this terminal alkyne, you got to start with the alkyne. 1, 2, 3, go to the left side, you get a longer chain. 4, 5, 6, 7. All right. So what we got a propyl group at position 3. So we go 3 propyl and 7. And we have this is 7 is heptide, right? And alkyne is at position 1. So 1 and 2, we take 1, the lowest one. So 1 heptide, right? Or 3 propyl, hep 1 I. Either way works. Okay. Sometimes if there's a 1 right here, we just ignore it. You can ignore 1. So we can do 3 propyl heptide. That works. Yep. So make sure that your parent chain includes the triple bond. Okay. All right. Next one. The triple bond, again, you know it already, so receive the lowest number. So look at right here. So you can start counting from the left side or from the right side, right? If you do from the right, of course, the substituent going to be the lowest, but this is an alkyne. Your priority going to go into the triple bond. Make is the lowest number, all right? So you're going to go from the left side, 1, 2, 3, 4, 5, 6, 7. This is heptine again, all right? There are 2 methyl groups on here on position 6. So we go 6,6 dimethyl. Don't forget di. A lot of students forget di here. 6,6 dimethyl. There are 2 methyl groups, and it's 7. So heptine. All right. So this heptine, and the triple bond is at position 3. We go 3 heptine. Do not count from the right side, all right? So we go 1, 2, 3, 4, 5, 6, 7. As you get a 2,2 dimethyl for heptine, but 4 is not compared to 3. We take 3, all right? Okay. You can also do hept 3-ine. Either way works. All right. Okay. All right. Now let's do IUPAC. Name this together in here. All right. So if there's a stereochemistry, I usually ignore it at the beginning. I just imagine or draw a new molecule that looks just like it, but without a stereochemistry. And we can always come back to the stereochemistry later. Okay. All right. So how do we start counting? So alkyne right here, start from the alkyne. So we go 1, 2, 3, 4, 5, 6, 7, 8. Chlorine at position 6. 2 methyl groups at position 3 and 7. All right. So we're going to go 6 chloro, 3, 7 di. Don't forget that. 3, 7 dimethyl. And this is an 8 carbon chain. So it's octyne. Alkyne at position 1, so 1 octyne. All right, you can ignore 1, it's fine. All right, 6 chloro, 3, 7 dimethyl octyne. All right, now adding the stereochemistry. Start with that carbon there. So let's see what's number 1. So carbon, carbon, carbon. This carbon connect to 3 and another carbon, so number 1 for sure. This carbon connect to 1 more carbon, number 2, and carbon that does not connect to any carbon, just hydrogen on it. All right, so this number 3, and priority 4. Hydrogen point toward you on the wedge line, but ignore it. So 1, 2, and 3 looks like S. Flip it to R. Don't forget to flip it. All right. Now another chiral center right there. So chlorine number 1 for sure. Number 2, this carbon here, and then carbon 3. Number 3, hydrogen point up front. So you got to flip it. Watch out. So 1, 2, and 3 look like right here. This is going to be an S. Flip it to R. All right. All right. So we have to include it. So we have 2 R's, one at position 3, the other one at position 6. All right. So we go 3R, comma, 6R, and then 6 chloro, 3, 7 dimethyl octane. Ta-da! That's it. All right. Okay. All right. Let's moving on.